Good morning. Today we're going to find the volume using the disk method.
Hey guys.
Hey Mo.
Hi Mo.
Mo, could you please read the example problem?
The area of a graph is bounded by y equals 2, x equals 4, the x-axis, and the y-axis. The graph is then rotated around the x-axis. What is the volume of the generated solid?
So to solve for the volume, we're going to set up an integral.
Mr. B,
Yes, Mark?
couldn't we just find the volume by using the equation for volume of a cylinder?
Yes, we could, but for the purposes of solving other types of rotational volume problems, we're going to set up an integral.
Alright.
So again, for the volume, we're going to take the integral of the cross-sectional area within the bounds. And since our graph is rotated, the cross-sectional area will be a circle. With our integral set up, we now need to plug in the radius. Our radius is 2, so that means our final integral is 0 to 4 of 4 pi dx. Manny, could you please solve this for us?
When you integrate 4 pi from 0 to 4, you get 4 pi times 4 minus 4 pi times 0, so 16 pi.
Yes, that is correct, but don't forget about units. In this problem it doesn't say units, so just say units cubed.
Oh, right, sorry.
Now let's try a tougher problem. Mo, could you please read the next example?
The area of a graph is bounded by y equals x squared, x equals 2, and the x-axis. The graph is then rotated around the y-axis. What is the volume of the generated solid?
For this problem, we're going to have to account for both the graph being perpendicular to the y-axis and the dead space. Since the graph is perpendicular to the y-axis, we're going to have to set up the integral for dy. And to remove the dead space, we're going to subtract the big radius squared from the little radius squared. Mark, with this new information, can you please solve for the volume?
I don't know. I'm still confused by dy. The dy means your radius will be determined by x values, so you're going to have to solve for x.
Oh, alright.
So the bigger radius is 2, and the smaller radius is the square root of y. So that means we take the integral of pi times 4 minus y from 0 to 2, and
Hold on, Mark. Since the integral is with respect to y, you're going to need to change the bounds.
my bad. So the integral is from 0 to 4. So when we integrate, we get pi in parentheses 4 times 4 minus 1/4 times 4 squared minus 0, which is 8 pi units cubed.
Good job, Mark. Now, remember, if the rotation's over a horizontal line, use dx. If the rotation's over a vertical line, use dy. Thank you very much for learning with me today. I enjoyed learning with you.